Yeah, so scale up. So we've established that demand for low carbon hydrogen is expected to increase fast, probably significantly, and that needs a fast response from um, every component of the hydrogen value chain. So from production by electrolyzers, and I'll generally focus on electrolytic hydrogen now when I'm talking about production. Transport and storage infrastructure, obviously critical to get the hydrogen from production centers to the points of demand, and technology for end users and applications. So the new applications that I've mentioned a minute ago, for example. So each of these three components are in quite different places on their scale up journey, or how ready they are for scale up. So electrolyzers, for example, they're growing or they're progressing fast. There are lots of large projects being announced, increasing in sizes actually, so gigawatts of scale being announced. Not yet proven at this massive scale, but they're not far off. You've got the 2.2 gigawatt NEOM project in Saudi Arabia under construction. It's due to start production, I think, next year, end of next year. So provided all goes well there, we're close to seeing alkaline electrolyzers demonstrated at the gigawatt scale. Otherwise, there are various other projects of a gigawatt and tens and hundreds of megawatt scale as well that include other electrolyzer technologies. Just to touch on the other components of the value chain, transport and storage infrastructure is also making progress in a lot of areas. Plans for pipelines in Europe are making progress, and there's quite a lot of activity in exploring the different hydrogen carrier options, so LOHCs, ammonia, some liquid hydrogen is being discussed as well. But some of our own research at ERM have found that there are significant gaps between the scale of infrastructure required to meet forecasted demands and what is actually being planned in terms of announced projects. So positive movement, probably not enough. Much more scale up needed on transport and storage infrastructure. And briefly on end use cases, the applications for hydrogen. It's a bit tricky to summarize quickly because the story is obviously quite different depending on which application you're looking at. Large scale ammonia production from electrolytic hydrogen, for example, you could say it's progressing well because, again, the NEOM project is going to produce ammonia from electrolytic hydrogen. So that should be demonstrating that within a couple of years. And then that's feeding into downstream ammonia cracking technology. So we should see that demonstrated within a couple of years. Heavy duty transport hasn't yet scaled significantly, but perhaps that's, there's some other challenges there that may be associated with cost rather than technology. So really getting to how do we scale up? How do we make that happen? I think starting broadly, I think we need to scale up skills. Knowledge and understanding with electrolyzer technology there's a lot to be done there. We need engineering design practices and design practices that support scale up. So modularization and standardizing designs that can achieve those economies of scale. But one point I'll go a little bit further on, to really enable projects, we need strong collaboration between organizations on these projects. So I think the key learnings of collaboration apply more widely. So I'll just go into that in a little more depth. But engineering work processes, approaches, methodologies, procedures may not apply in the same way on very large scale projects. So if I can get kind of specific to illustrate the point, the commissioning of a single 10 megawatt electrolyzer the commissioning procedure for a single 10 megawatt electrolyzer is unlikely to be suitable for a plant that is 100 10 megawatt electrolyzers. And the skills and knowledge to produce that scaled up version of the procedure may or may not be within the knowledge base of an electrolyzer manufacturer. So perhaps, maybe that task is better suited to an EPC, an engineering contractor, or a plant operator. And if that procedure then leads to a change in design, what's the impact of that? Are there changes in equipment required? And if you do need to change equipment, how expensive is that going to be on 110 megawatt electrolyzers? And can you mitigate that risk by ensuring that you collaborate earlier on the projects? So, is it getting an engineering contractor and an electrolyzer manufacturer working together earlier? to make sure that the large scale facility is considered much earlier on in that design process to try and mitigate that challenge. So scale up isn't just this thing but bigger. It's a totally different facility, you know, with different methodologies, different procedures, different approaches. And I think the best way that you can tackle that kind of challenge is to ensure that the right knowledge is available, and that you can come through, and that can come through collaboration and partnerships, and between the right organizations. Yeah, so thank you for indulging me on that kind of fairly detailed example, but hopefully it kind of illustrates one of the key things that I think really needs to be applied when you're thinking about how to scale up electrolyzer project.